Hello, welcome to question 89 of the exam practice medley. Right, this question is about charge, and it tells us that there are two particles and has a repelling force. Now, before I answer this question, I just want to let you know that there are some clues in this exam questions. First of all, repelling force and two particles. So there are two charged particles and repelling force. So let's imagine that the particle is a sphere. Because they repel, so therefore they can either be both positively charged or they are both negatively charged. Regardless if they are positive or negative, it doesn't matter. There is a repelling force. Okay, so it doesn't require us to find out if it's all plus or all minus. So, but their weights it's also again is not to do with their mass either. But what I want you to know is that the only equations or the law or the finding. This is a very well-known topic called the Coulomb's law. So, the Coulomb's law. Okay, this is the law which analyzes the force between or acting against each particle. So, the Coulomb's law is equal to, so force is given by the magnitude of the charge, Q1, Q2, so you can call that Q1 or Q2. So in A-level physics, we use capital Q instead of lower q. And then it's divided by 4 pi. This is permittivity of free space, epsilon 0, times by the inverse square distance. So it's strange that you think is the distance, but we in the Coulomb's law is convention to use the distance between the two particle separation from center to the center to be r. Okay, so and then the only thing you need to find is the charge on the second particle. So to get 2 marks, first is that you rearrange the formula so that the Q2 is on as a subject. So we can do that first. So we don't want any of this denominator, so we can take all of that because it's divided. So I can times all of the denominators by this fraction. So I'm going to times this by 4 pi mu naught r squared. And this side I will times 4 pi epsilon naught r squared. And so that it will cancel out. So that gives me Q1, Q2 equal to 4 pi epsilon naught permittivity of free space times r squared times f. So therefore, divide both sides by Q1, then you can say that Q2 is equal to 4 pi epsilon naught r squared f over Q1. And then you just have to substitute the values in, and then you can get the answer for the charge. Now, one thing I want to also point out, any variable in the denominator is the inverse of. That means the bigger the separation, the smaller the force. The inverse meaning the bigger of something, the smaller on the other thing. Okay, so it is really true because the smaller the distance, which means the separation becomes closer, the force, so if you drop that lower, the force will increase because they're getting closer. So the repelling force will be strong. Okay, so this is the inverse square, sometimes we call this. Okay, so Q2 is equal to 4 pi. Now epsilon naught off the top of my head, I can always remember 8.85. The power, sometimes I get it mixed up with -15, but it's -12. And then I times that by the separation, which is 1.2 square, and then times by the force, 172, and all over the charge for the third one of the particle, which is 0.3. So if you put that in the calculator, you'll find that Q2 is equal to 9.18, which is 2 decimal place, times 10 to the power of -8. Now charge is measured in Coulomb. If you forget, just remember the Coulomb's law. Okay, so that's it, and I really reckon this could be coming up in the January 2020 exam. I haven't seen these questions asked most recently. Good luck.